Hey guys, HackerSploit here, back again with another video. Welcome back to the Penetration Testing Bootcamp. In this video, or in this set of videos, we're going to be taking a look at vulnerability scanning with Nessus. Alright, so in regards to where we are within this particular course or bootcamp, you can see that we've covered the pen testing essentials, the process of setting up a pen testing lab, passive information gathering, active information gathering, enumeration, and now we're at vulnerability scanning. We've already covered how to use OpenVAS as a vulnerability scanner. We're now going to be taking a look at how to use Nessus and a few other proprietary vulnerability scanning tools that are free but also have commercial plans available. After that, of course, we'll be moving into exploitation, and that's of course going to be focused on Windows and Linux, and then of course antivirus, evasion, privilege escalation and post-exploitation, web app pen testing, and then we'll take a look at the last few sections which will deal with network penetration testing and password cracking. Alright, so as I said, this particular video and again these set of videos that will follow after will be focused on the process of performing vulnerability scans with Nessus. Alright, so what we will be covering exactly within this set of videos is going to be the following. In this video, we'll be taking a look or getting an introduction to vulnerability scanning. We'll also take a look at the vulnerability management lifecycle, and then the next set of videos will deal with the process of installing and configuring Nessus, and then finally how to perform vulnerability scanning with Nessus. Alright, so when it comes down to vulnerability scanning, it's very important that you make the actual distinction between vulnerability scanning and vulnerability management. Alright, so vulnerability scanning is a subset of a vulnerability management program, and I'll get to that in a second. But vulnerability scanning is essentially the process of scanning and identifying vulnerabilities, misconfigurations, or flaws in operating systems or software, right? If you have a group of computers on a network and you want to scan them for vulnerabilities or misconfigurations that could lead to potential exploitation, you can automate this process using a vulnerability scanner. All right, now, as I've just mentioned here, vulnerability scanning can be performed either manually or automatically by leveraging automated vulnerability scanning tools like Nessus. Now, when it comes down to pen testing and the role vulnerability scanning plays within pen testing, it's a fairly simple process here, in that all we're trying to do is we're trying to identify vulnerabilities that can be exploited, right? Now, as I said, this video and this set of videos are not going to be focused on a vulnerability management plan or the process of setting up a vulnerability management plan. Instead, we'll be focused on automating things like port scanning, banner grabbing, operating system and service detection, and of course vulnerability detection with an automated vulnerability scanner like Nessus. All right, so as I said, I've just mentioned the features, the typical features associated with a automated vulnerability scanner. Just going through them again. With a vulnerability scanner, they provide you with the ability to perform, or they essentially automate port scanning in order to identify open ports on the target system or the target systems. And then once it's obtained a list of open ports on the target, it'll then perform banner grabbing. And of course, we've already taken a look at how we can do this with Netcat or with Nmap, but in this case, we're automating the process, right? So from the banners, Nessus is able to identify the operating system and the service versions of the services that are running on these ports or that are running on the target system. And then of course, with all of this information, Nessus then performs vulnerability detection or vulnerability scanning, and the way it does this is through signature-based detection. So Nessus or any other vulnerability scanning utilities come with a signature database that is essentially a list of vulnerabilities with their corresponding signatures. And those signatures are essentially what is used to detect vulnerabilities either in the operating system or for individual pieces of software. So for example, if I have a web server or a Linux server that's running VS-FTPD 2.3.4, Nessus already has a signature for the vulnerabilities that essentially target, or the exploits or the vulnerabilities that affect that specific version of VS-FTPD. Right, and the way the signature works, or the way signature-based detection works, is a certain vulnerability like VSFTPD, can be identified firstly by performing port scanning, identifying that FTP is running on the target, regardless of the port. Secondly, banner grabbing essentially gets the service version. In this case, banner grabbing would essentially help Nessus identify the version of VSFTPD running, and then that signature is automatically matched based on the findings from a vulnerability scan. Right? Now, when it comes down to automated vulnerability scans, as I've already mentioned, they utilize signature-based detection, or a signature database rather, in order to detect vulnerabilities. As a result, it is recommended to always keep your signature database updated in order to avoid any false negatives. Now, this is something that I mentioned quite a lot when we were taking a look at how to perform vulnerability scanning with OpenVAS. And that is that you need to keep your vulnerability database or your signature database regularly updated so that you avoid any false negatives. So for example, if a vulnerability is released, or there is a write-up or disclosure for a specific vulnerability for the Windows operating system, then you need to make sure that you have that signature in your database so that you can detect that vulnerability on your systems within your network. Now, as I said, when I'm talking about the signature database and how often they're updated, this will depend on the company or the product or solution that you're utilizing and how frequently they update their signature databases. So typically you should get a vulnerability signature update for your signature database within 5 days to a week. Some are even pushed out even faster based or depending on their severity, right? Now, the key thing to note here, and this is where you need to draw the distinction between manual vulnerability scanning and automated vulnerability scanning. Automated vulnerability scanners are relatively efficient when compared to or with manual vulnerability scanning. However, signature-based detection is also prone to providing false positives, and as a result, you must be able to assess the vulnerability manually. The key point here is that while vulnerability scanners like Nessus or OpenVAS are extremely useful and efficient and simplify the process of identifying vulnerabilities, they, number one, in some cases will provide you with false positives based on whatever happened during the scan. And secondly, you should have the ability to assess a vulnerability or the actual exposure, or confirm the existence of a vulnerability on the target system manually. So if you get a vulnerability report after you've performed a vulnerability scan on one of your target systems or one of the systems on your network, again, it's really important that you actually confirm that these vulnerabilities exist, or this specific version of a particular service does have a vulnerability. And again, you should never rely on using one technique over the other. It should always be a process that actually involves a form of synergy, in that when you perform an automated test, you should be able to confirm, and vice versa, right? So they should be used together as opposed to relying on one technique over the other. Now, just to close up on automated vulnerability scanning, it's very important to understand that it's much faster and much more efficient than manual vulnerability scanning. However, the speed and the results of an automated vulnerability scan will be affected by the following factors. All right, so number one, the type of connection. Are you performing a vulnerability scan on a remote system, right? And if that is the case, is your internet, or could your internet connection be a bottleneck there? And of course, irregardless of that, if you're running a scan on a local network, then it's going to be much faster than doing it or scanning a system across the internet, right? The second thing you need to note, and this is really related to the types of results that you will be able to identify, and that is whether you're actually performing a vulnerability scan with credentials or without credentials, because tools like OpenVAS or Nessus allow you to provide credentials in that Nessus will actually use those credentials to log in to the system and then perform scans, perform scans that require authentication, and those will give you, much better results in regards to vulnerabilities. However, if you are trying to simulate a pen test, then again, that might not be necessary. The third consideration that you need to take into, or that you need to actually consider rather, is the number of hosts that are being scanned. Because if you scan a large amount of systems or hosts, at a single, given point in time, so maybe 10 systems, it's going to take a while, right? So you need to take that into consideration, and you need to take into consideration the purpose that those those hosts or those servers are actually serving on the network. So you actually need to be very conscious of that, and whether or not those scans are going to affect their functionality. The final factor that you need to take into consideration is the system resources that are allotted to the host that is running the vulnerability scanner. So if you're going to set up Nessus on an Ubuntu server, for example, and that's just a very basic example, it needs to have the necessary system resources to run as efficiently as possible. And most of these vulnerability scanners require a lot of system resources, and honestly speaking, are resource hogs, but for obvious reasons. They're doing a lot of things in the background, apart from scanning for ports, actively comparing results with the signature database, etc., etc. Now, a key thing that I want to highlight here, and it's very important to understand, is that vulnerability scanning should not be confused or misconstrued as a vulnerability management program, or misconstrued with the vulnerability management lifecycle, in that what we are focusing on primarily is going to be the process of performing the vulnerability scan. So that is assessment, and then of course generating reports, reports that are useful either to the company and the various levels levels of management and the relative shareholders or stakeholders and parties that are going to require that information to begin remediation and verification, as to whether or not those vulnerabilities have been patched. So again, when you're talking about a vulnerability management program or the vulnerability management lifecycle, this is the process that actually takes place. Number one, you identify all the assets that need to be secured, right? So if you're in a company, you absolutely find every asset. When I mention, or when I say asset, what I mean is every system, every workstation, every laptop that's part of the organization, every Docker container, everything, right? You essentially discover and you get a list of everything that needs to be scanned and secured. You then go about prioritizing assets based on their role within the company. So for example, you may want to prioritize employee workstations if your company is facing a lot of attacks, a lot of phishing attacks. But of course, I'm just using a basic example here. Second one would be, of course, your servers that are hosting a web application or a database. So you want to prioritize assets based on their functionality and their value to the company, right? So once you've prioritized the assets that need to be scanned or assessed first, then you can go ahead and begin scanning them, and that's what we're going to be focusing on, right? So we start scanning them, identifying vulnerabilities. We then generate the reports from our scans, and then these reports are then sent to the remediation team, whether they are developers or system administrators. They then implement patches or fixes. And then those particular patches or fixes are then verified by performing another scan in order to verify that these patches are effective and the vulnerability has been mitigated or the vulnerability has been patched, right? And that process, keeps on going. So you can see how useful this is within a company. However, in the context of a penetration test, we're focused with identifying vulnerabilities and then, of course, assessing the viability essentially assessing whether they can be exploited or not, because that's what a penetration test is. And then, of course, the data we get from the scans can then be also included within our penetration testing report. As I said, if you're performing a penetration test, I don't recommend relying on vulnerability scanning or automated vulnerability scanners. You should be able to assess each vulnerability manually, and that's why penetration testers are different from a vulnerability scanner. So you need to take that into consideration. That being said, that's going to be it for this video. In the next video, we'll begin the process of setting up and installing Nessus. And then after that, we'll get started with the process of performing a vulnerability scan with Nessus, and then we'll move on to generating reports, etc., etc. So that's going to be it for this video, and I'll be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.